they don't change.
Specifically for the Concordia Women Awards ceremony, and I will leave the floor to Professor Carminati. Barbara, please go ahead.
Thanks. Hope you can hear me. Good afternoon. It's really a pleasure to me to welcome you to this section that, as you can see, is dedicated to women in cybersecurity. As you might be aware, since the start of the Concordia project, we have devoted effort and time in defining and implementing action to promote women in cybersecurity. During the first Open Door 3 years ago, we launched the Concordia Manifesto in collaboration with EXO Women for Cyber. The manifesto is basically a document where we analyze the situation of women in different domains related to cybersecurity, and we identify 3 main objectives that we, as a Concordia, we would like to achieve. This was just our starting point. Then, based on this objective, we have identified a set of and start implementing a set of action, indeed to incentivize the presence of women in cybersecurity. One of the action is indeed the reason for which we are here today. So Concordia has established the Women Awards, the Concordia Women Awards, to celebrate women in cybersecurity, to recognize outstanding women working in cybersecurity, and to encourage young female working in cybersecurity to continue their career. The Concordia Women Awards are defined as a series of awards that will cover different areas of the cybersecurity ecosystem, and the first has been devoted to research category. In particular, to promote the women at various stages of their careers, these awards include 3 main categories, as you can see from this slide. The first is a master student, so we want to recognize young female that since the master study, the master thesis, they are interested in a topic related to cybersecurity and privacy. Then we have the PhD student that, as you can figure out, we are targeting PhD student that have investigated topics related to cybersecurity in their PhD study. And finally, the early career researcher. So we aim to prize young female researchers that, what does it mean young? Here, young means that they have discussed their PhD thesis no more than 5 years ago. So we received several excellent applications. We are really happy about that. We formed a selection committee that I would like to personally thank. In this slide here, you see the name of the professor and the person that has been involved in this committee. The committee has did a great job because they evaluated each application. And then based on the judgment, we are happy to announce the winner of these awards. So the awards winner are for the master students award with Pantelitsa Leonidou from Cyprus University of Technology. For PhD student award is Martina Šestak from University of Maribor. And for early career research is Eleonora Losiouk from University of Padua. So I want to express my congratulations to Pantelitsa, Martina, and Eleonora. But this session is not only to announce and to congratulate with you, but it's to give the opportunity to introduce yourself and your topics. So in this section now we are going to leave the floor to them. We start with Eleonora, and then we go from Martina and Pantelitsa. So to all the audience, feel free to pose questions in the audience, in the chat, and then I will moderate the question. So Eleonora, the floor is yours. I will stop sharing.
And
so you should be able to share your.
Okay, can you see the presentation?
Yeah.
Okay. So good afternoon, everyone. It's a pleasure to be here. So thank you very much to Professor Carminati and all the people that have been involved, not only in this big project called Concordia, but also in this such a big event and initiative, which is the Concordia Women Awards. I'm really proud to be selected for the Early Career Award today. So what I would like to share with you is my brief career so far. So I discussed my PhD 3 years ago, and the current project, the current research activities that I'm working on. So very briefly, I started and I have a background in bioengineering, and I got a PhD in bioengineering and bioinformatics in 2018 from the University of Padua, and then I moved to Padua to join the Spritz Security and Privacy Research Group led by Professor Conti, where I've been a postdoc till last May, when I won the assistant professorship position, and I'm still working in the Spritz Research Group. From a research point of view, my interest mainly regards the Android security, and in particular the Android virtualization technique, which have been used so far for developing new defense mechanisms, but also new attacks, and which I've also used for writing several project proposals, among which three actually were considered successful. So the first one was a Marie Curie Global Fellowship, which was considered a successful project last year, and for which I was awarded a Seal of Excellence. And the second one was a Fulbright Fellowship, which is also the thanks to which today I'm currently calling you from Berkeley, where I'm visiting the International Computer Science Institute. And finally, this year, recently, I was awarded the Early Career Women Research Award from Concordia. Over my career, the event that made me switch from the my previous background and research topic that was more connected to bioengineering towards the current one, which is cybersecurity, was an internship at the PFL that I did during my last year of my PhD in 2017, which was the opportunity for me to visit a research group working on mobile health cybersecurity projects. And then it was also I got the chance to start working in cybersecurity in that occasion. Besides doing research, you know that at the university we do a lot of stuff. So I'm involved in several nice activities like the Cyber Challenge event, which is an educational program for which we're going to move towards the 5th edition next year. I've been from the very first edition, the local instructor for the UniPD team, and the first time in the first edition we won the national prize. I've been also involved in proposing a patent 2 years ago, and in organizing several international events, like 2 years ago, several PhD schools on cybersecurity topics. Last year, an event to promote and to share the experience and the contribution of women in both cybersecurity and computer science. And recently, we organized with other partners of this Arcus program, a summer school in cybersecurity last September. Finally, I'm very proud about the mobile security course that I am a teacher of, and I've been able to set up from scratch in Padua within the framework of the new cybersecurity master degree that has just started, and I'm really proud of. Concerning the research activities that I'm working on, over the past few years, I've been, as I said, I've been working in the Android virtualization technique from different point of views, and I recently switched to something that might be more challenging and tough as an overall scope and purpose. So the target of my current activities is the Android security program, which is sponsored and promoted by Google to support the responsible disclosure of vulnerabilities that everyone can find in the Android operating system. Even though the program is pretty simple and involves a few steps, some of these steps might be bottlenecks and can affect the security of the Android operating systems every day. So everything starts with the identification of a vulnerability in an Android operating system, which can be done by anyone, a researcher, passionate developer. Anyone can find a vulnerability and can responsibly disclose it to Google, which has to evaluate the vulnerability and eventually to release this associated security patch, which is published as part of the Android official operating system. However, Android is a very complex ecosystem because besides having the official Android version, which runs on Google devices, we also have a multitude of different customized Android operating systems that run on the different devices provided by the mobile vendors, such as Samsung or Huawei. So if you have a Samsung device, you will have a different customized Android version with respect to the one that might be running in a Huawei device. And this problem, this fragmentation problem, actually is significant because whenever there is an update, a security update provided by Google, it is responsibility of the mobile vendors to integrate such update in their own customized version. And sometimes they don't do that. So at the end, what happens is that mobile users might never receive the security update, either because Google does not develop the security patch for the vulnerability that has been detected, or because the mobile vendors do not integrate the security patch in their own customized device. What I'm working currently is to propose an alternative approach to solve this problem and to provide a new solution that helps with the development, but also the distribution of the security patches, which relies on the Android virtualization technique. Such technique allows basically to have multiple instances of the Android operating system that run at the application layer, so on top of the Android native operating system, and that are independent, do not have dependencies from the underlying operating system itself. So everything is handled by an application which is called container that is responsible for creating the virtual environment. And within the virtual environment, you can have multiple applications running at the same time. So the idea is to enable the development of the security patches as security plugins of a virtual environment, so that at runtime, the mobile users can simply download the security plugins and install within the virtual environment and provide the security protections they would like to the app that are running in the same virtual environment. Going a little bit more specific within this technique, everything goes around the internal design of such a container application, which involves, of course, several plugin apps, which are the one that we run in the virtual environment, and one module, which is the most important one, that is called proxy module, because it is involved in the interception of all the system calls and APIs that are called by the plugin app, and their forwarding towards the Android framework. So basically, this module is able to change at runtime the behavior of the application that are executed in the virtual environment. So exploiting or relying on this proxy module, the plan is to, as I said, is to enable the runtime dynamic loading and execution of several security plugins that will be enhance the security protection of the virtual environment, and at the end provide the security patches that are associated to a vulnerability that has been found. Thank you for the attention, and I'm happy to answer any question if there is.
Thank you, Eleonora. Let me see if there is question. I don't see in the chat question, but no. But I actually curiosity because by the way, congratulations for your Fulbright. Wonder what are if you can tell, what are you doing in Berkeley and what are the topic of your Fulbright? If it's related to this.
Yeah, it's actually related. I mean, Android virtualization is a very huge technique that can be addressed from several perspectives. So even here, I joined the group of Professor Serge Egelman, and they are doing like privacy. They're focusing on privacy issues. And another time, the virtualization technique could be, let's say, a new approach for solving some privacy issues that they have encountered on the Android operating system. So we are trying to merge our background knowledge in order to provide something that could be new for the Android community. So at least that's what we can manage.
Okay, sounds a good plan. Thank you, Eleonora. Thank you
very much.
I think we can go on for the next presentation, which is Martina. As you can take the floor.
Thank you. Just let me share real quick. Okay. Okay, now you should be able to see it. Okay, so hello everyone. On my side, my name is Martina Šestak. I am a PhD student here at the Faculty of Electrical Engineering and Computer Science in Maribor in Slovenia. I am this year's PhD student award winner, so thank you committee. Thank you, organizers, for this recognition. And I'm currently employed also as a teaching assistant and a researcher working on various projects here at the university. My areas of interest mostly revolve around graph databases. So I have a background in software engineering. So besides the research part, my days are occupied also by development and implementing things that can be used widely. But in my PhD studies, I have worked on publishing as many research papers that the time allows us. I am yet to obtain my title so that I can start writing project proposals and things that my other colleague is already doing there. These are some of the publications that I have published so far. And now in the following slides, I'm just going to try to give you a brief look into what I do in my PhD. So I'm working on developing a model, an abstract model that allows you to, let's say, detect or observe some suspicious patterns, potentially fraudulent patterns in networks. So what I'm trying to do is combine my, let's say, graph database knowledge together with the graph theory foundations, and then apply these findings in the fraud detection domain here. So just to give you a brief context to the research problem, so we have many domains today that are basically, let's say, networks with highly connected data. And now graphs are considered to be mathematical representations of these networks. So this is something that's an axiomatic statement there. So graph database technology is something that was developed with that purpose, so that we can apply the graph theory concepts there.
Sorry to interrupt.
Yeah.
But could you please try to reload your presentation, because I see a green box in some words are.
Sorry. Okay. Let me just start it there. Thank you. Okay.
Sorry for that, but since this.
Yeah, is it better now?
Okay, now the box are no.
Okay, let me just check something with my display settings. Sorry. Really
No,
quickly.
because some words were covered by the box, and maybe you refer to that sentence as not.
Okay. Quickly. Okay.
Seems to be the WebEx box, huh? Something like that, I guess.
Maybe I can.
Can you move or reduce?
Yeah, like that. Hide it something. Is it better now? Okay, great.
Thank you so much.
Thank you. Okay, so what I was saying is that basically the graph databases are then a technology that became popular with the social networks in the last decade there. And what's, let's say, new and popular about this technology is that you can represent this network data directly or more natively as a graph, basically, because the underlying data storage structure in graph databases is a graph. So you have nodes, you have edges, and then you have labels of nodes, so that you know that we have, for instance, users in a product review network, we have reviews, products, and stuff, things like that. And we have properties describing these nodes. And this kind of technology is, let's say, optimized for storing these connections, because the main idea is that when you are researching or analyzing networks, let's say in most cases, the most relevant or important information for you would be to analyze the connections between nodes. And this is something that graph databases are quite good in covering there. Now, on the other side, we have the fraud detection problem, where you're trying to study the network in order to analyze any potentially fraudulent behaviors. Another question here that arises is that if you can represent networks as graphs, does fraud detection in network come down to identifying patterns in a graph? So using graph algorithms that would allow you to analyze such networks here. The answer is more or less mostly yes. So if you look at the literature, there will be, let's say, two types of categories of approaches. So you will have the modern data mining, machine learning based approaches, where you study the network, you study the graph basically, and using different statistics such as what is the degree of a node and things like that, you are able to, let's say, perform clustering of nodes which are potentially fraudsters in your network, or you can classify, label a specific node as a fraudulent node or not, and things like that. And then on the other side, you have the model-based reasoning approaches, which rely more on the expertise and the knowledge of the domain experts, basically. So you have experts, let's say, telling you or helping you build a database of fraudulent patterns. And then for any new pattern that you have in your system, in your network, you can use this database to say, okay, this new pattern might be also fraudulent or not. And this is, let's say, a starting point for my model. So I'm more leaning towards the model-based approach there, where I'm trying to build an abstract K-card model, which is based on the graph theory concepts and can be implemented in modern graph databases so that you can actually use it on your graph or network data stored in a graph database and therefore prevent or detect possible frauds in your network. So the model itself encompasses various things. So let's say it's a comprehensive approach, which allows you to specify what might be fraud or not. And this is done based on business rules of the domain. So basically, I am using the cardinality constraints concept, which allows you to limit, for instance, how many reviews a user can write for a given product. So if this number exceeds, let's say, 2 in a month, then I know, okay, something potentially fraudulent might be happening in my network. So basically, this is the kind of a rule that you specify in the system, in the database, and then you can use the model's algorithm to check the existing network data or have it as a preventive measure to help you maintain the database integrity so that it cannot happen that a user wants to write a new review on your data, on your products. So this is a visual representation of such a model here. So if I were to have a graph database with a graph with similar structure, for instance, I know that potentially fraudulent patterns in my product review networks are when users are writing massively positive reviews for the same products, and they're all rated 5 or 1 if they're massively negative, fake negative reviews. And we don't know if the purchase has been made. So they're simply generating massively fake reviews here. And the model enables you to specify such a rule that would make sure that in your database that situation doesn't happen, or if it already happens, so that you can detect where it happened. So which are the connections that are or subgraphs basically which are fraudulent there. So if we were to have such a network here with all of the users, the products that they wrote and things like that, and I would say, okay, a user can write at most 1 review for the same product if he hasn't purchased it, then we can run the algorithms, which would then detect us, okay, we have more than 1 relationship here or here, for instance. And in that case, we could say, this is the subgraph where I have, for instance, this user writing massively fake negative reviews, trying to diminish the value of some product or something like that, or massively positive reviews, so that the grade in general of that product is better, for instance. And just to sum up briefly the impact of this PhD research, so it has been already published, and now I'm just working towards my dissertation here, but this model should be abstract enough. It's based on the graph theory concepts, and it's something similar that, somewhat similar. It extends the work that has been done in relational databases, but it hasn't been done for graph databases. Also, I would say the biggest value is the applicability of this model because it's abstract, but also comes with a set of algorithms that allow you to implement it in modern GDBMSs, in modern graph databases, and you can specify complex patterns for detecting fraudulent behavior in your networks here. And of course, there may be even more that I haven't discovered yet, but more or less, this is it. And this is all for my presentation. If you have any questions, I would be very happy to answer them.
Thanks, Martina. Let me see if there are questions. I need to for another monitor. I don't see, but I will check after. Yeah, first, congratulations for your thesis discussion. I follow your presentation. It's really good topic. I have some curiosity for that. Maybe I can ask to you. The first is about the business rule. You mentioned business rule, and I wonder if the business rule for fraud detection is something that are very, let's say, clear and well defined, or is something that you need to evaluate on your data set. And in this case, how you can plan to evaluate in the graph data set.
Yes, so these business rules are, let's say, a subset of, I mean, there could be various rules that would help us to detect such patterns, but mostly these rules are focused on the number of interactions between entities. So if I say how many times does a user write a review, for instance, that's something that can be transformed into something that monitors the connections in my graph. So how many relationships I have in my network for my network elements that I can map or represent via a graph in a graph database. And then these rules can be, within this model can be used. Of course, it doesn't cover all of the rules, all possible rules, but let's say a subset of these rules that are focusing on the connections between network elements.
But this is just my curiosity. Does the graph modeling give the opportunity to have a more complex business rule compared to, for example, the database model, the traditional database model? Do you have the opportunity to define new business rules? Or something that maybe you have considered in your research?
Yeah, that's an interesting thought there. It doesn't at the moment, and this is precisely why I'm working on extending it, because this business rule part, the procedures, so business logic incorporated in a database. In graph databases, this is quite, let's say, a work in progress. So there's still a lot to do before it can match the relational databases, for instance. But the thing with the graph model there is that you can directly represent these connections between the networks. So it's much more natively done here. So it's at the moment, it already allows me to specify some more complex things there. And I expect that it could also do it should there be more complex mechanisms developed there.
Good. So
thank you.
New challenge to face.
Yeah, quite a big thing there.
Thanks for your presentation, and we go to the list, but the last but not the least. Sorry, we have Pantelitsa. So you're here.
Hello, everyone. Let me first share my screen.
Yeah, the floor is yours.
Perfect. I think that you can see my screen, right?
Yes.
Okay, first, I would like to thank you, Professor Carminati, for introducing me to the panel, and also to just express how honored I feel about the Master Awards. My name is Pantelitsa Leonidou, and now I received the Master's Award, but now I am a PhD candidate at Cyprus University of Technology. I'm working on cyber safety topic under the cybersecurity. And the study that I was doing during my master degree was about how to enhance the social media experience of minors by using adaptable and usable cyber safety tools. Let me minimize this. Okay, the motivation behind the study was that since the social media applications are not designed and developed especially for minor users, and the minors used to overuse the social media applications, and sometimes they are using multiple social media applications that their parents don't even know that they're using. And that exposed them to many risks and dangers that are not capable of coping with. Some of the cyber safety threats that the minors can face online can be cyberbullying, inappropriate sexual or violent content. They can be exposed to hate speech videos or posts. They might post some sensitive information or receive some sexual grooming messages in their chats, or by sending pictures to unknown people. And what we try to solve here is to protect the minors when they are online. And since that is not a very new problem, we know that the researchers and developers have designed and developed many cyber safety tools to protect the minors online. But the problem is that most of the existing applications, after studying the literature, we realize that are underused by the parents since they have many usability issues, and they are offer services that are mostly for monitoring the activities of the minors or restricting their access to those applications. And that is most of the times too privacy invasive for older children, like the adolescents. And that makes those applications unwanted for the minors, and also grows tension between the parents and the children. So the aim in our study was to redesign and improve the cyber safety tools, or actually the methodology of designing and developing the cyber safety tools in order to satisfy the requirements also for the children. The two main approaches in the literature that are used to design those applications is the parental control approach, which is the more traditional one, where we have the monitoring tools and the restriction tools, where they apply some limits on the time or the applications that the children can use, or maybe the parents can monitor the chats or the profiles of their children in order to understand if they are exposed to any risk, and then they need to manually do something about it, maybe offline or online. It depends on the tools. But the problem of this approach is that it mostly offers interface only for the parents, and on the children device there is only some background services that are running without any interface for the children. And that's, as I said before, too privacy invasive for the adolescents, and sometimes make the children's social media experience to suffer. And that this approach is mostly suggested for children of young age. And then more modern approach is the self-regulation approach, where we have the self-monitoring and self-regulation tools. And also we have the risk coping guidance of the minor. So in those applications, we allow the children to be exposed to the risks at a level in order to learn how to monitor their own activities, to set some regulation techniques and some risk coping techniques. And those applications are promoting the collaboration between the parents and the children, and usually offer interface for both the parents and the children. And in those applications, the parents' role is mostly to offer help in the risk coping when the minors face any online risk. And this approach is mostly suggested for the adolescents. Some other suggested features in order to increase the usability of those applications, the cybersafety applications, is to add some educational features for both parents and children, to have always some direct links or connections from the applications to some organizations that are specialized in the online safety, where the parents and the minors can report incidents or get some online help. And the third feature is to add some gamification features on the interfaces of the children in order to make the applications more friendly for the minors. So the idea was to, instead of having one approach in an application, either the parental control or the self-regulation, is to have a more adaptive approach for minor cybersafety. That this application can be adapted based on some factors, such as the age of the minor, the family values, the variation of the different parental styles that someone can follow, or maybe some cultural characteristics. And by having an adaptive approach, then we aim to fulfill both the parents and their children's requirements. And the idea is to start collecting all the existing application features and user requirements about cybersafety applications, and to identify different categories of the parents and children categories, and also identify which features are go into under each category, and then identify the conditions where the application needs to adjust its feature. For example, a condition can be when the child gets older, or maybe when a child starts having some dangerous activities, and this is monitored by the parent, and then they can change maybe the settings and give him less freedom in his activities and more control. Then we were about to identify the latest technologies for each feature, and then design and develop the adaptive cybersafety application. And in the end, evaluate this application with real users and go back again in the circle by collecting the new, maybe some problems that they will face or new requirements. Since that was a very, it was an idea to just suggest a new and a different approach, but we didn't have the time during my studies to focus on implementing the whole application. I needed to move to a more focused point. So my master's thesis was mostly on federated learning and how it can be used in order to develop privacy preserving cybersafety tools. And since we have, instead of having the monitoring and blocking features on the cybersafety applications, we suggest giving some filtering features that they can automatically detect the online threats by using machine learning algorithms in order to give less control over the minors' activities from their parents. So just by having some filters using machine learning models, we want to detect the online threats and notify the minors. But the challenge here is that most of the time the data sets that are needed to train such models is the data is too sensitive, or sometimes we need to have again and again up-to-date data in order to follow the trends of the social media. So the idea was to use the federated learning instead of having decentralized machine learning, and instead of having centralized data set in a central unit, we have multiple clients, which are the users, and it can be the device of each user. It can be a laptop, it can be a phone, it can be a sensor, it can be a smartwatch or whatever. And instead of sending their data to a central unit to train the model, then instead we have the central unit sending the model to the clients, and then they need to train the data with their local data. And then just send back to the central unit the model updates. So we don't have the data leaving from the devices of the users, so we are following the privacy preserving value. So in the end, the model is getting trained without expose the data of the minors or of the users in any central unit. So we applied the federated learning. We did some experiments actually to build a model, a text classifier model to detect aggressive text. And I will just give some of the observations here and the findings. We find that we can apply federated learning in the use case of cybersafety tools, since we were able to obtain a model with a good performance, which was similar or was approaching the performance of the model that was trained in the centralized approach. But we also find out that we need a lot of clients. That means also a lot of data and a big number of federated learning rounds in order to have the model to get trained and converge its performance. And we also had an experiment with some devices like my laptop, for example, to check how the laptop was allocating its resources during an NFL training, since I need to use my own resources to train the model locally and then send it back to the central unit. So that's it. That's what my thesis was about and what I was studying during my master thesis and my master studies. I'm currently, I've just started my PhD, so I think I will keep on working on similar topics. I would be glad to answer any questions if you have.
Thank you, Pantelitsa. Let me see if there are any questions from the chat. I hope I'm checking the correct chat, but I don't see question in case Antonio could just highlight question that I missed. But
no, I confirm there is no question.
okay, no, because I just have first congratulations, Pantelitsa, to be admitted to the PhD program. So it's really good that you did a master thesis in cybersecurity and you continue with a PhD. I think this is a really good path for you, but to encourage also for other young female, let's say, researcher. I have a curiosity about the model, because my understanding is that your master thesis you are going to exploit the results of the master thesis in your PhD work. You show a roadmap of, I guess, what you're going to do in the PhD. And I'm wondering, this tool, in which of the steps that you show it in the roadmap are going to be used, if to, let's say, change a little bit the federated learning, or as it is, you're going to apply it?
Yes, you mean in the roadmap that I showed before for the how to build a more adaptive approach for them? Yeah, there is, for sure we need to find, the features are there. Many applications have many different features that you can find it, but you can find one application that has some of those features, and then some other applications have different features. So the idea is to try to collect them all together, and on some that we can work on, such as machine learning models that they can. I think I will work mostly on this automatic detection or filtering of the social media applications.
But the idea is to keep the federated learning, or it was, based on your experience in the master thesis, federated learning can be easily applied in this scenario. on your roadmap, or it's something that you need to be
I
considered?
think we need to, it needs to be considered because you need to have the, the people accepting giving their
The data.
data, or actually not giving their data, but train the models on their devices. So we will try to test that if it can work, because we have already implemented, in the lab that I'm working with, they have implemented these cyber safety tools, and we can try to install them for some, I don't know, families with minor children, and then check if that can work with a few data, and maybe in a combination with a centralized model and also with the, but yeah, it's something that I will work on
Okay.
and study more.
Thanks. Thanks for
Thank
the
you
nice
very much.
presentation. Thanks, Eleonora, Martina, Pantelitsa, for all the presentation. I'm hope, but I'm actually sure that this awards is just the first, one of the first achievements that you're going to achieve in your career. So hope to see you around. I'm sure that I will see some of you around. And so I leave again, congratulations. I don't see comments or chats, so I leave the floor. We are in the last session, so that's the point. I leave the floor to Antonio. I guess you are going to.
Yeah, sure. So thank you very much, Barbara, and all of you for this session. And I will thank you also, like the audience, for today. So we are going to meet tomorrow again at 10. So we will, you can join the platform all day long, so from early morning. And after this session, if you want, the lounge are open, if you want like to chat with other participants. And also like, please visit the exhibition area where you can find like between industrial booths, but also like research posters. So thank you very much to everybody and have a nice evening.
Thank you very much again.
Bye-bye.
Bye.
Bye.
Bye-bye.